So for this one, I have, it's drawn for you, right? So it makes it a lot easier. To find the height of a cliff that is inaccessible, right? They can't climb it. A surveyor measures a baseline AC of 400, and they already have it labeled. In the horizontal plane, so this is actually two planes. So this is supposed to be on the ground and upwards, right? So it's like up like this. So on the horizontal plane here, ABC is on the ground, and this part here is supposed to be the mountain heading upwards. So it's supposed to be a 3D diagram. It's not. In the horizontal plane, ABC, angle A is 27, angle C is 35, it's there. In the vertical plane, so this is heading up, so it's like you folded the page up. So this is supposed to be the wall heading upwards, right? So like this. BCT, in the vertical plane, BTC, this is 18. Sorry, my arrow got mixed up, so it's 18. Determine, this is vertical, and it says, determine the cliff height BT. So the only thing I want to point out with this one, the only reason it's a little bit harder, you have to know the cliff height BT, this line here, is at what angle? If I say height, 90, right? So it doesn't specifically say, but you have to know that that is 90 because of the word height. So it says it has a height of. So when a question says it has a height of or find the height, we're assuming it's at 90 degrees. So they didn't specifically say it in this question, but it is a BT, is a height. Okay, so then we're just going to answer it. I have two triangles connected together. You go to this triangle first, obviously, and say, I need to find BT. That's the one I'm trying to find. But based on this SOHCAHTOA, this triangle, this right triangle, I have only one angle and nothing else. So what would be nice to find would be the connector. So this one here that connects the two triangles together. So I used to say for the grade 10 students, you try to find the connecting side. So find this side, and then it gives you one of the sides of the right angle, and then I can use SOHCAHTOA with the rest of it. So to find this side here, I go, okay, can I use SOHCAHTOA? No, because it's not 90 degrees on for this triangle. Can I use sine law or cosine law? The first thing you see here is that it's got the two angles. So I would fill in the missing angle. So this one here is 180 minus 35 and minus the 27. You don't have to show me that, but that gives me 118. Right? So you don't have to show me that, but fill in that 118. Based on that, now we know, and we've talked about this a couple times now, does that make sense? That this is going to be a nice case for sine law. Okay, so at first it looked like it wasn't possible, but once we fill in that angle, it is a nice case for sine law. So I would just do BC over sine of 27 equals 400 over sine of 118. Find your BC, approximately nearest meter. It says nearest meter. Right, so nearest meter. Getting 206, rounded properly or no? 206. We're okay. So then that makes this side here 206. Nearest meter. All right, and right angles, we can go just back to SOHCAHTOA. I want to make sure that we don't forget that. I have the adjacent. I want the opposite, so tan. Tan of 18 equals BT over 206, and then BT is approximately, what do we get? $67? I got 67 too. Good, 67. Okay, and then just a quick sentence. So therefore, the cliff height is 67, and I'm assuming, is it meters? Meters. Okay, so you are allowed to use SOHCAHTOA wherever it's a 90 degree. Just be careful when it says height, that does mean 90 degree. That's it. Okay, so now you got all the knowledge. Everything's in your brain. Any questions with that?